Hi, in this video I will tell you what is an absolute experimental absolute max or mean of a function. We have studied relative max mean, relative extremum of a function. Now this is absolute. Let me start with one graph to show the difference or maybe the relation. Let's see, this is the function, let's say, on the interval a b, the closed interval a b. So I have this last points. Then well, we know based on what we have learned that this and that, those are relative max mean of the function. So let me just write, this is relative max value and this is relative mean value of the function. But when you look closely and carefully, you notice that the relative max is not actually the maximum value of the function. There are these whole values of the function which are bigger than, greater than the value of the function at that relative max. So relative max is just max around that point, but it doesn't mean that it can be the largest value of the function on the given interval. And then this example really shows itself that, okay, that's relative max, but the absolute max, the value which is the highest value of the function on that interval is this. So this is absolute max value. How about absolute mean value, meaning that what is the largest, the smallest value of the function on this interval? Well, if you look again a little bit closely, you notice that, okay, this relative mean actually is the smallest value. So in this case happens to be that the point here, the relative mean, is actually absolute mean value of f on that interval. So this shows that a relative max and relative mean need not to be the absolute ones. They can be, and this is an example. So let me just write the definition here. Definition of relative max, absolute max mean. Well, like always, we assume that we have a function defined on an interval which that interval contains point C. Then we say FC is an absolute maximum value of f on interval I if the value of the function at that point is bigger than all the other values of the function on that interval. So x in I, for all x's in I. And similarly, we have absolute mean. FC is an absolute mean value of f on I if, well, value of the function at C is less than equal to any other value in that interval. And as we had before, the terminology, if C is an absolute extremum if it is, sorry, let me write this completely, is an absolute extremum of f on I if it is either an absolute max or absolute mean of f on. So this wording is very similar to the case we had for the relative. When you don't want to mention it is max or mean, you just know that it is one of these, you use the extremum. Here we are dealing with absolute, so you say absolute extremum if it is either absolute max or absolute mean of the function on that interval. There's one more remark here that is that, well, then what is the difference between absolute and relative? Well, in the case of, in the relative definition, relative extremum definitions, when we were defining that, the interval we were choosing was just there exists an interval. The interval at which value of f is maximum or minimum is just one given interval just exists, is exist. But when it comes to absolute, it's not saying restrict yourself around that point. It is on the whole interval given from the beginning. So relative means that it is max min only around that point, but absolute means that it is max or min on the whole interval. Okay, this is just a definition, and then in the next videos we will try to find methods through which we can detect absolute extremum of a function.